Well, hi and welcome to my shop, and thank you so much for joining me. It's March 21st. It's a very cold day here again. Winter has definitely come back. Not going to get above freezing today, which is a little cold for this time of year. So if you're tuning in to my channel for the first time, I'm going to tell you a little bit about what to expect here. So this is not my radio, this belongs to somebody else. I don't really know about whether it works or not offhand, and that's kind of where I'm starting. I'm starting just from there. There's the radio. Can you make it work? I think there's a chance the owner of this radio has never plugged it in for fear, and that can be modified. Fear, plugging it in, you don't know what's going to happen. So on my videos, what I do is I come in the shop, I turn on the camera, and I start to work. And when I'm done, after an hour or something of that sort, with quite a number of breaks and stops in the meantime, I then put together all the pieces of video I shot and publish it on YouTube with very, very little editing, almost no editing. So that means that I'm not really showing you how to do things. I'm just doing them in front of you, and stuff goes right, stuff goes wrong, and along the way I like to talk, so I'm talking a lot. Sometimes I'm not thinking much about what I'm talking about, and sometimes what's coming out of my mouth is not true because I'm just wrong. I got wrong ideas in my head, or once in a while I mean to say blue and the word red comes out of my mouth, which is something you've probably noticed when you're watching live newscasters. Occasionally you know they meant to say right when they said left, and you can tell they're not even aware. And so that can happen in my videos. Also, if there's problem, this is a fairly simple radio, but if the radio starts developing problems, I have to do some troubleshooting. I'm going to go off in directions that might be different than what you yourself might do. So you might watch me go down a couple of roads, dead ends. You know they're dead ends. I don't know they're dead ends. So there'll be a little bit of that. Ultimately, when I'm done, this radio should be working great. That's what I hope. So probably going to be 2, 3, 4 videos on this radio. I don't know. I'm just guessing, but it's not a very large radio. It's just a 5-tube radio. Yes, it actually has 5 tubes in it. And that's something about these little 5-tube radios are actually more dangerous than the bigger ones with more tubes and a big power transformer. So I'll be talking a little bit about that too. If you're a hobbyist and you've got a 5-tube radio and you think it'd be great to fix it up, and it would and it will be great to fix it up, there's a lot more to it than you might expect when you start into this. So even though it's a small radio, it has all the stages and parts of a big radio, and so it has various circuits in it you need to understand and the like. So let's just check this guy out now. So this is a Philco. This is called a Boomerang radio, so I've learned this morning. I have the schematic for it. Actually, it's a service manual, and I think we're going to take a peek at it before I do too much to it. It's got Loctite tubes in it. These are tubes that actually snap into the tube sockets, and then they're held in a little better that way. Nothing special about them other than that. I think they were probably intended for car radios, but I don't really know for sure. What else can we say about this? So the model number. There's a model number up here. It says model number 10710. Couldn't find anything about that model number that's on the sticker up there. And it says model 49501-121. So I eventually found this radio under 49501 as the model number on a couple of different websites. Okay. Let's turn the dial here. Feels normal. The dial's probably direct drive to the capacitor. Yeah, there's no string involved inside. And there's no back for this radio. There once was. You can see the screws here. Of course there was a back for it. The back is missing, but the good thing is the antenna was not mounted on the back of this radio. A lot of these small radios, there's an antenna mounted on the back, and that antenna really belongs to that radio. It's not just a random loop of wire. It's a tuned circuit. It's part of the radio. And in this case, the antenna is here. It's mounted inside the cabinet. Well, that's a good thing and not a good thing, because when I'm going to be taking the chassis out, the antenna is not coming with it. It's glued in here. I'm not about to break all the glue off. So the lead wires are going to restrict how far out the chassis can come, and it's also going to mean the cabinet has to stay here the whole time. The speaker appears to be mounted, so I'm looking to see if it's on the cabinet. Yeah, it's mounted to the chassis. So when I pull the chassis out, the speaker will come right out with it. In a lot of radios, the speaker is mounted onto the cabinet, and you have to be careful about that deal. Would I plug this in and turn it on just like this? I think it's probably wiser to look carefully inside it, to see if there's anything weird or strange in there that shouldn't be in there before you turn it on. I think we need to take it out and take a look at it. So underneath the cabinet, underneath the chassis rather. So pull off these knobs. Some terrible sound in there. For crying out loud! What's this? Is there two things? Maybe that's a tone. Okay, so the little spring has come out of here. You don't want to lose that. That's what makes it stick on the shaft. And the same thing in this knob. There's a little metal piece that acts as a spring. This one too. Funny is that I gotta lose that. It's all one thing. Yeah, it's just decorative, even though it's separate. Okay. Oh, that's interesting. Look at the name they've got here. Philco Transitone. Isn't that a curious name for a tube radio? Transitone, transistor tone, Was that the marketing department trying to fool people into thinking this is more modern than it is? Transitone. Transitone. I don't know. Got to be a play on the word transistor, I think. Okay. Now to take this out of here. Bottom, aha, a little bit of information on the bottom here. So there it says the model number quite clearly here, 49501, code 121. I suppose as they're building these, they're making small changes and giving the subsequent radios a different code number. I think that's what's going on. The tubes in here, 7A8, 14A7, 14B6, 35Y4, 50A5. These are all relatively unusual tubes, especially these 14A7, 14B6. These are unusual. I'm sure they're rare tubes. 50A5, never even heard of that. 50B5, 50C5, but I've never heard of a 50A5. And a 35Y4. Again, I don't think I have any of these. There is a dial light hidden up in here. Well, let's hope we don't run into tube trouble. 3 screws holding it in. So if you get a radio like this, should you just plug it in and see what happens? I never do that. When I plug them into a regular outlet, when I plug these things in to see what's going to happen, I plug it into a system that restricts the amount of power that's going to be available to the radio, in case there's something really seriously wrong in it, like a short circuit. Remember the antenna wires here. I'm going to bring this out and swing it this way. Wires are fairly long, actually. Put that there. Okay. First, we'll look on top here. There's a fair bit of dust in here. Not surprising, though. I don't think it's of any real significance. We have a permanent magnet speaker here, of course. I think that pretty much has to be the case with a 5-tube radio. The two IF cans here, they are slug tuned, which means that they have to be tuned from underneath and above. You have two tuning capacitors here. They eventually have to be adjusted during alignment. Okay. Let's tip it. I think we got to tip it this way. We don't have too much choice. Maybe actually this way. Oh, that's good enough for now. It's almost certainly the original power cord. Appears to be in pretty good shape. Surprising. Non-polarized plug. So I think just at a glance, nobody's been in this radio before. No one's looked at it. You know, no repair guy or anything like that. So it looks. Let me take a closer look here. So we have some physically large capacitors here. This one in particular, obviously. Typical sized ones over here. Important coil soaked in wax right here. It's a little odd looking. Looks like a wire that's been overheated, but I wouldn't bet on that. Hard to overheat a wire. So nothing seriously jumping out here. Don't see that the radio's been on fire or anything like that. So we're going to look at it with this close-up camera just to be sure. And before we switch to that camera, I'm going to freeze its focus. So if you just bear with me for a moment while I do that. I'm just pulling up the dialog box for that camera. We're going to freeze its focus like that. Okay, let's take a closer look in here, although I don't think we're going to be surprised by anything. Let's start right down here at the volume control. What's this attached to? Oh, there's the wire, black wire. That wire, okay. Of course I thought, hey, one of the wires is missing on the volume control. One of the things we want to look for are any connections to the metal chassis, any soldered connections. While we're looking in here, so we're looking for any parts that appear to have overheated. So see those marks on the wire there, on this red wire? Those look like soldering iron strikes from whoever was doing the soldering in here. Looks like they nailed this too. It's it's underneath the chassis, so it's out of reach of finger, so it doesn't really matter. But and these pink wires go into this guy. Now this guy is almost certainly shot. This is the main filter capacitor. It's involved in the process of changing the power from alternating current to DC current that you need in the radio. And what is it? It's a 160 volt 20, 150 volt 20, 20, 20, 20 microfarads, 20 microfarads, and 20 microfarads. So 3 20 microfarad capacitors. Not very big. Somewhere there's going to be a fairly large wattage resistor associated with these red wires. Let's see if we can spot it. It's going to be usually right around here. Large wattage resistor. Up in behind here? Well, I don't see it, but maybe we'll come across it as we go. Acrad? Who came up with that name for a capacitor? Give me one of those Acrads. There's the coil I was talking about. That's wax covered. So, what do you think? Think we should turn this guy on? Hey, what's that? Spider. Spider's living in here. Not much of a surprise in that. There's nothing here that is leaping out and telling me, oh my god, turn this thing on, it's going to blow. And that doesn't look like that. But, probably turn it on, it's going to hum like a son of a gun because of this capacitor. So what I'm going to do is I'm going to stop for a bit and drink some coffee, and then I think we are going to turn this on and see what happens. But again, I'll be powering it up through a method to control the amount of power that comes in the radio. Control to some degree. So let me just explain that a little bit. So I have a fantastic device for doing that. That's this guy. I don't make much use of him. I can change the voltage here up and down, as you can see. Normally it's set right around 120 or so. The output of this gray cord, eventually comes around to here. So this white extension cord, in fact, is what's coming from here. The gray plug is going to this meter. So when the power comes on here, this meter will pop up to life. This meter is not a zero meter. It starts at 100 volts, goes to 140, so it's usually hanging around in here. This device I put on here, this is a really handy thing. You'd be good to have one of these in your home. This one, this one's called a kilowatt, but there's other makers of it. I've had this for quite a few years now. And what it does is it just reports different things to you. The voltage of your outlet, the amount of current you're drawing, the amount of power you're consuming. Lots of interesting things. This is a great device. Here it's just handy. It shows me the voltage right on the outlet, and I plug all projects into here. But what I really do to control the power in a project is I feed the power through these light bulbs, these two here. These ones are spare here. These two light bulbs. So actually the power that gets to here actually has to go through the filament of these light bulbs. Sometimes I have both in, sometimes I have only one in. For this radio, small radio, I would have only one. So I'm loosening off the other one. So just this bulb now. Yeah, but a rather silly control panel over here. I have a main switch on off, and then I have a directing switch. Directs the power to here, either through those bulbs or straight to here. So it just depends. If there's nothing plugged in here. If I go down, then the power goes through the bulbs to the outlet and into the project. And if I flip this up, then the power goes the other way. Now listen to the sound of the switch. You'll hear me moving this switch. but you won't see my hand much of the time. The camera will be down here, but when you hear that, you know what I'm up to. And I usually say what I'm up to. I usually talk too much, actually. So, okay, good. I'm going to go take a little break. Then we're going to turn this radio on and see what it does. And so 80% says it's going to hum. 20% says it'll work. That's my vote. Just before we get going on the radio, let's just scan through the service manual here. The idea here, this is a large service manual, so I want to look through it and just find out, the different chapters and areas and what's in here. Like, there's a lot for such a small radio. So here we go. Some opening information. Troubleshooting. So that's unusual. I don't think I've ever seen a service manual with a section on troubleshooting right in here. Wow. Interesting. And they get a trouble table. Well, that's different. Section 2, audio circuits. What's the first section? Power supply, audio circuits, troubleshooting. Shows you the circuitry parts, where they're located in that. Very interesting. I've never seen this in a service manual. Although I have noticed that a lot of Philco service manuals are really well done. Normal indication, possible cause. Of abnormal indication. More troubleshooting. IF stages, the detector, and the AVC circuits. It shows you the particular componentry again, where it's located in the radio. Look, I was looking for that. Let me stop here for a minute. This is the connection to the chassis. It's being made through this capacitor here. And since we're now looking at the schematic, C303, let's try to remember that. And we'll take a peek at the schematic. Try to find C303 on the schematic. So more troubleshooting, RF and converter circuits. Wow, this is really quite the manual. Here we are with the schematic. Okay, we're at 1/2 the schematic. What was that capacitor number? Look at this. Look at this. So here's that capacitor, C303. Big one. Look what it says. Part of C303. And it shows a coil here. That's very unusual. That's unusual. Part of C303. We got to find this and find out what's going on with it. 0.2 is a large capacitor, and it showed us where it was. Where was it? 303 over here. Okay, moving on. So schematic here. What they've done here is they've heavied up certain lines on the schematic, and these are showing the signal path along the heavy line here. The lighter lines are just showing voltages that are supplied to the tubes and stuff like that. Here's the antenna on the back of the radio. Ground to chassis for loop operation. So a lot of people would hook up loop antenna. Wait a minute, there's a loop antenna, this antenna. For loop operation. Okay, I don't want to understand anything, I just want to know what's in here, and maybe something I have to study later. They're just showing the symbols that are used on the schematic. Here's the other half of the schematic. Here's the output tube. Cathode resistor, 130 ohm cathode resistor. Bypass capacitor, C201. Get down here, power supply filter capacitor is 101. There's 3 sections to it, 20, 25, and 30. Now, didn't I see 20, 20, 20 on the one I looked at? I think it was 20, 20, 20. There's a capacitor here that's right across the incoming power. We have to find that capacitor for sure and replace this one. We'll be replacing almost certainly all the paper wax capacitors in the radio. This particular one is important because it's right across the power line. So if this thing begins to leak seriously, well, you got the pressure of Niagara Falls pushing on it. So look at how long this thing is. Now what are we at? Alignment instructions on 2 pages. Okay, great big table. Symbolization. We must be getting to the bottom here now. Alignment procedures. Here they're showing you where the alignment adjustments are. I saw most of them already. Accessory plug. I don't remember there being an accessory plug on the back of this radio. There is. There is a very strange looking accessory plug. What kind of accessories? Now we have a circuit description, where the engineer gets to boast about his radio that he designed. Replacement list. This is where the company gets to sell parts. And that's the end of the road. Let's read the circuit description. What did the engineer have to say? Philco models 49501, 49501I are 5-tube table model super heterodyne radios providing reception in the standard broadcast band. A high impedance loop aerial normally provides adequate signal pickup. An external aerial may be connected if desired by detaching the aerial lead from the chassis and connecting it to the external aerial lead-in. Do not use a ground. The loop, I should put this in bold print. The loop aerial is coupled to the 7A8 converter tube. The aerial and oscillator circuits are tuned by ganged variable condensers, and the oscillator rotator section plates are properly shaped to obtain tracking, thus eliminating the necessity for a padding condenser. I'm going to flip to the camera just for a moment. I'm going to show you what they're talking about there. So if you look at the tuning capacitor here, you see a large set of plates here and only a small set here. That's exactly what they're talking about. This small set is the one that's driving the local oscillator, and it's been shaped so it doesn't need a second trimmer capacitor, not only the parallel one that's here. But on a lot of radios, these sections are identical. They're the same number of plates and everything. And so to compensate for the fact that there's too much for the local oscillator, they put a capacitor in series with it. What happens when you hook up a series capacitor? You reduce the overall capacitance. Parallel you increase, series you reduce. So to reduce it, because there's too much stuff there, they put a series one in, and they call it a pad. Padder, they use the term padder. P-A-D-D-E-R, padder, or a pad, instead of using the word trimmer, which they would use if it was in parallel with that capacitor. So, any idea what I'm talking about? Well, if you know a little bit about electronics, you know what I'm talking about. So basically, from a manufacturing point of view, this is harder to manufacture, but saves you a trimmer capacitor in your radio parts. And I guess, one trimmer capacitor saved over, how many of these radios do you think they made? 5,000? That adds up. So here are. So this was to talk about it. So this is what they say again. I'm going to read it again. Variable condensers and the oscillator rotator section plates are properly shaped to obtain tracking, thus eliminating the necessity of a series padding condenser. When they say tracking, they mean as you tune the radio, the pointer is pointing at a certain frequency, and this oscillator plates have been shaped so the proper frequency is tuned out of the radio, so the numbers match what you're actually picking up. That's what it's talking about. Big deal to an engineer. The 7A8 converter is transformer coupled to the 14A7 IF amplifier, which is also transformer coupled to the diodes of the 14B6 second detector, first audio amplifier. So notice I'm using the word detector here, where we tend to call what they're calling the second detector, we tend to just call it the detector. And what they didn't use the term first detector. Interesting. They didn't actually call it the first detector, but the converter tube is often called a detector tube also. Confused? AVC voltage, and they didn't capitalize this property. It should be capital, capital, capital. Automatic volume control voltage is applied to the control grids of both the IF amplifier and the converter tubes. Triode section of the 4V6, the first audio stage, it is resistance coupled to the 50A5 output tube. This is all normal stuff. The output tube is transformer coupled to a permanent magnet speaker, which we already looked at. A DC, again, didn't capitalize the C here. DC operating voltages are supplied from a 35Y4 half-wave rectifier. You know why this isn't capitalized? Because it was typed by a typist, not an engineer. The engineer wrote it up. When she, capital, and then everything else is small. Okay, the typist did that. Filtered by a 3-section resistor condenser network. Let's read this once again. DC operating voltage is applied from a 35Y4 half-wave rectifier and filtered by a 3-section resistor condenser network. Okay, this is what is probably not going to work. It's probably going to hum. Condenser 303 is a special condenser. We already figured that one out. Inductively wound to form a series-tuned circuit resonant at the intermediate frequency. Oh my gosh! This condenser offers less impedance at this frequency than at conventional condenser, and thus permits higher IF gain with no tendency toward instability. Okay, so this engineer's screaming this from the hilltop here. Look what I've done. I stuck in a capacitor that has some kind of winding in it, and the result is better output. No tendency towards instability. What kind of instability? The 150,000 ohm resistor R102 prevents hum which might otherwise occur under conditions of high humidity. What? I've never, what? We gotta find this one. The 150,000 ohm resistor R102 prevents hum which might otherwise occur under conditions of high humidity. Well, how can a resistor do that? R102. Let's go find it. R102. Start looking. So they may have numbered these by section. So see the R2, R201. This is section number 2. So I forgot. Oh, well, that's all it took. I forgot what I'm looking for. 102. That's all it took. 102. So it'd be in this front section up here. R1. That's a 4. R3. Maybe 1 is in the power supply. R1. R101. R102. Oh no, can anybody see what's going on here? Shoot. Well, there it is. What's it doing? I think there's something else in here. The humidity. The anti-humidity resistor. Really? I never heard of such a thing. Huh. Okay, that's it for looking at the schematic here. I think for now, interesting. So the special capacitor with the built-in coil, or so it sounds, or something about this capacitor is very special, and I certainly don't have one of these special capacitors. So we don't want to change this one unless there's some real need for it. It looks to be in good shape. They all look to be actually in fairly good shape. So, but we don't want to be changing this one. And the other thing was, what was the other thing? It was a resistor. Wasn't what was this magic resistor, which goodness knows where it is. These are the terminals for some kind of auxiliary thing. These are not antenna terminals. I'm not sure what this really is. They just mentioned auxiliary power or something like that. I have to look again at the manual, but these are not antenna inputs or ground inputs. There's something else. Could it be for another source of audio? It's not typical in a radio of this sort to do that kind of thing, like have a way to hook up a phonograph or something like that. Okay, well, I think we should start this guy up. I'm not afraid. Are you afraid? I'm not afraid. Like I said, the most likely thing is it's just going to hum like a son of a gun and not much more. And I'm going to be running the power through the light bulb here. So normally what happens when you turn on a radio like this, a tube radio, the heaters in the tubes are cold, they're room temperature, and the resistance is quite low at that point. They're going to heat up very high, up to 600, 700, 800 degrees or something like that. The resistance will be much higher then, but at first the resistance is very low. So when you turn on the on switch, a large amount of current will flow through the heaters briefly, and during that time this light will come on. So you see it kind of come on, and then it'll fade down as the heaters heat up. Once the heaters heat up, the tubes are ready to operate and draw their own current, particularly the rectifier tube. Once a rectifier tube is hot, it begins to build up a voltage, a high voltage, and that voltage is then delivered to the other tubes, and they all start working. They all start drawing current once this high voltage comes in. At that point, the light bulb, which will probably have gotten fairly low, maybe even not even visible at this point, is a small radio, will start coming brighter again. It won't be anywhere near its normal brightness unless something really bad is happening. And that's the thing. If there somehow is a short circuit in here, and really not, chances are just about zero, but let's suppose there was, maybe that capacitor I saw that's across the power line is shorted right out. So it's a dead short right on the outlet. So turn on the power. If I didn't have the light in the circuit, then this thing would draw about 1,000,000 amps and make the water go backwards at Niagara Falls. So we don't want that to happen. So instead, this light will get bright because the power is going to go through it. It's going to get bright. That'll restrict the power. The power can be no more than what this light bulb would allow through if I put 120 volts on it. What is this, a 20-watt light bulb? Something like that. And we shall be saved, and Niagara Falls will not reverse. Although if I could reverse Niagara Falls from here, I could probably become pretty famous pretty fast. Yeah, not going to happen. First thing we want to do is make sure the on-off switch turns things off. So we're going to make sure it's switched off, and then we're going to apply the power. There's the snap. You can see my hand going for the switch I was talking about. So we're watching, just eyes on the light bulb. Unless you see voluminous amounts of smoke come out of here, then you might want to look here. But otherwise, watching the light up, down, and then up. And as it comes up, sound comes out of the speaker. But there's a good chance, turn it on and hum. It's just going to hum. We'll see. Here we go. I get my hand on the switch so I can turn it off quick. Did I turn it on? No. So it's on with the volume up just a little bit. Here we go. Bright light, very bright light. Bright light. It's dulling down. I can see it. You probably can't. The camera does things. It's dulling down. Slowly, slowly. You only have like 50 volts on the radio instead of the usual 120. But the low voltage means the heaters heat very slowly. So the bulb goes down very slowly. So it's getting very dull now. You don't hear a hum yet. You can see the light bulb up in here is glowing ever so slightly. Now we're at 60 volts. That's not enough to operate a radio like this. But it's enough to find out what's happening to it. Oh my gosh. Here comes the buzz. Okay, so we don't have to listen to much more than that. Okay, so what that proved to me is the filter capacitor is shot. Surprise, surprise, surprise. Okay, so I gotta think about those antenna wires every time I tip this radio. Okay, well, first order of business is to replace this capacitor and try again. Okay, we're going to replace that capacitor. This could be a replacement. There's a band here that's holding it in, and it's pretty bent up in this area, as if it's been taken off and put back on. This may already be a replacement, and that's not uncommon in these radios. This capacitor gets replaced during the normal service life of the can I get this off here? Looks like it goes up and around this way. Yeah, I can't get that off easy. I can get it off the other side easier, I think. Yeah, new capacitor won't require this band. We're going to pull it out of here. We'll just push it there for now. This is the capacitor here. Now, let's look again at the ratings on it. I can't see it. What does that say? 20, 20, 20. But the book, the schematic said 30, 20, 20, didn't it? Something like that. So this is 20, 20, 20. Each one of these wires has the same size capacitor, and they're all rated the same voltage too. 150, 150, 150. Good. All three of these are in the power supply. That's right. That's right. So what was bypassing the output to cathode resistor? I don't know. So I'm going to cut this. I'm going to preserve the wires in the radio. As much as possible. Didn't I cut that? Yeah. I would test this, but there's really no reason to. Playing the radio and hearing that hum is the test of this capacitor, and it failed. Once a capacitor shot like that, this is probably full of moisture and it's leaky and who knows what's going on in it. You really can't put it on a regular test set and read the capacitance or anything like that. Those capacitance tests only work with a capacitor that's healthy. They don't work on tired old capacitors. So I gotta get 3 capacitors. Their rating has to be at least 160 volts, let's say. 3 of them at 20. You know, I've got a whole bunch at 50. What if I put 350s in there instead of 320s? Gotta think about that. And drink some coffee and think about that. So I have 3 47 microfarad capacitors to go in here. And what was in there is a 20, 20, 20. But look at the schematic. It's a 30, 25, and 20. If I make this more like a 50 and a 50 and a 50, what would happen? Why aren't they 50, 50, 50? Probably cost. Probably not necessary to go that big. And the bigger the capacitor, the more the cost. So from a cost point of view in designing a radio, they're going to make this as small as they can get away with. Small and cheap. So this one is connected directly to the rectifier tube. So there's no restrictive resistor in here. So conceivably a heavy charge current flows into this first capacitor, pulling hard on the rectifier. But of course the rectifier warms up slowly. So there isn't not like turn on the power and whack. You're trying to dump a pile of current into a completely empty capacitor. Since the heater warms up slowly, I don't think there's any problem here. Going from 30 to 50 is probably make no difference in the radio at all. What about this one now? So once the voltage builds up here, it's going to start spilling through this resistor into this empty capacitor. But again, it's all going to go kind of slow. I think. What I'm worried about here is you've put in too big a capacitor, you pull too much current during the startup of the radio and burn out this resistor or damage this rectifier. That's what's going on in my head, and I'm just pondering whether that's really a concern here. And way out here, only a 20. Why not a 50 here? Again, I think it's a cost thing. The benefit of going above 20 isn't that great. There's a little more money involved, so why do it from a manufacturing point of view? I can't imagine there's going to be a problem here. If there is, what would happen? The worst case, you burn out this guy somehow. I don't know exactly how. Burn up this resistor, just put a new one in, and learn your lesson. I don't think anything really bad can happen here. We still got to deal with this guy. He's high on the list also to deal with. But we won't deal with it right now. Let's just do these three. We'll do it with the 50 I've got. I haven't got many options, and I don't think there's going to be a problem. That's my assessment. Okay, so I'm going to go ahead. I'm going to bundle these guys up. I'm going to put them in. I'm going to solder them up. Use the wires that are here already. You don't have to worry about which wire is going where. They're all the same. Okay, great. Okay, I'll get that done. Then we're going to try this radio again. So the way I go about doing this is quite simple. I just take the 3 capacitors, twist together the negative lead from each one, so they kind of becomes one capacitor with 3 terminals, just like the original. Then, because these are going to have high voltage on them, I'm going to slip a cover over them, cut them to fit, position them in here somewhere, run these red wires over to these leads, and be done. And then sometimes I can solder this negative down and make everything rigid right off the negative leads. That's possible here too, maybe. If I can kind of, or maybe I'll stick it under the strap again. Figure out how to strap them in. Okay, I will get it done. Okay, I've got the capacitors in here. I used the bracket again to hold them. I used the wires to lead up to them. Tried to make the connections here as close to the capacitor as possible. Like this red one, I got right up close to it. The yellow ones are a little sticking out, so I had to put a little cover in here, but there's high voltage sitting right here. So don't touch that. And this is sitting in a plastic case. There's no metal coming up. There's no metal plate or anything coming up to it. But nevertheless, let's just check. If you're not careful, you can put parts in which are actually sticking out. Everything looks fine. You put the radio back in, and now the parts get compressed into the cabinet because you weren't paying attention, and bingo, short circuit occurs. So we're just going to come over here like that. So nothing is sticking out here. We're ready to try it again. We're going to see what happens. These big capacitors in there. Now, assuming the radio survives startup, which I'm pretty sure it will, the bigger capacitors don't have, they won't hurt anything, that's for sure. And they're in the direction of goodness. Bigger is better to a point. So, I mean, once the capacitors are big enough to eliminate the hum, making them bigger, there's nothing left to eliminate. So that's kind of what's happened here, but I think it's going to be okay. First, switch off. Plug in. So first, we're going to power it up with the switch off, because where I was working is right on the power. I shouldn't say that. It's not right on the power. Okay, so nothing should happen. Nothing has happened. The ultimate voltage here is, if we give it the full treatment here, I'm going to set this to 115. That's pretty typical. But that's not what the radio is going to experience, because I've got this bulb in here. So this voltage is going to disappear as soon as I turn it on. Let's turn it on with the switch this time. No, let's not. I'm such a chicken. I tell you, Okay, here we go. We're powering it up. What do I expect to have happen? Just going to work. Just going to work. big bright dim bulb. This is called a dim bulb system. I don't think I mentioned that. And if you type into Google dim bulb system old radio or something like that, you can read all about what I'm doing with these light bulbs here. Okay, so the light's going down. The radio should come on. It's got 60 volts on it. It's really pretty low, but let's just leave it. Turn the volume up. Full blast. Turn it down. Okay, so I'm going to screw another light bulb in. This will raise the supply voltage, probably right close to full voltage here, once you get two of these lights in. Okay, we're at 108. That's more than enough to make the radio operate. Any smoke? Flames? Nothing happening. Turn it up. Dirty volume control here. Sounds like a radio. Let's tune it. Like a lousy radio. So we're hearing sound coming out of the speaker. Now I'm going to put my hand near the antenna. And what that proves is that if you tickle the antenna circuits, the speaker responds. So everything in between is largely working. Is it working perfectly? Probably not. Is it working good enough? Well, we're not hearing any stations. So this is possible. The antenna here is going to be directional, and let's get it up on the rotating surface here. Trying not to break the wires. Okay. Now we can rotate. Let's see, stations are going to be where the capacitor is mostly closed. Bad volume control there. Yeah, okay, so we're going to do a couple things here. I'm going to turn the power off. I'm going to clean the volume control and make sure it's working properly. And we're going to hook up an external antenna, or at least have an external antenna affecting the radio to see if we can't get some stations on it right now. Sure sounds like it's close. So that wire I just connected, this is going to an outdoor antenna. Very special antenna. And I have to do a couple things, and we're going to... There was something else. Oh, I forgot. Mr. Short-Term Memory. Okay, let's clean up the volume control. Often I do these with the radio or whatever switched on, but not in this case. I'm pretty sure these wires are going to break off here at some point from all the monkey business, as long as they break off one at a time. So what I want to do is tip this up. So gravity will force the fluid down into the volume control here. What I don't like about this stuff, I don't like this stuff very much. Can never tell if you're spraying anything out of it or just gas. We'll know when we test it. Don't tug those wires, Jeff. Don't tug on those wires. We will know when we turn it on. So that was one thing, and the other thing was, oh yeah, the antenna. So what I'm going to do first, I'm not going to hook up the antenna directly to the radio. I'm going to hook it up indirectly. The antenna is going to be connected to this simple 3-turn coil of wire, and then I can just put this near the radio's antenna, and hopefully some of the signal will kind of cross over and it'll boost the radio. We'll see. It may not work. Okay, plug it back in. Did we fix this volume control? Okay, power going on. Very good. Now probably those capacitors I put in there remain charged a fair bit. Maybe not. But okay, we're going to give it it's 109 is okay. I'm going to leave the lights in the dim bulb lights in, just in case something happens here. Here we are. Okay, volume control, there's no more crackling. That's done. Okay, now we're trying to tune in a station. Okay, we're going to touch the antenna. Well, it affects it here. Okay, we're going to stick the loop in here because we're not hearing any stations. And this is not likely to help, but we'll see. I just kind of jam it in here. So that noise you hear right now, that's interference from my house. That's not the radio. That's unfortunate interference. I've never been able to track it down. This is the French CBC station. Unfortunately, again, that interference is right on top of it. That reception's good. Let's go back here. We're definitely tuned to a station. I'll take out the booster here. Can you do it, radio? So the antenna in here is directional, so I'm trying different directions. But no. So the reason the radio is not working could be from misalignment. Some of the adjustments here need to be made and it will come to better life. Weak tube is possible. I'm putting in a stronger signal when I do this, of course. Compensate for something that's weak. The good news is we know everything works. All the tubes work, speaker works, everything works, radio tunes. So there's nothing seriously wrong here, which is typical of these radios. There's usually nothing seriously wrong with them. And let me just cut the power here, pull this out. The next step, for this, well, I have options here. One is test the tubes. Why would I do that? Because the radio is weak. But you know, it might be weak because of these capacitors. I'm going to try to delay the tube testing thing as long as possible. Last radio I did, I never did test the tubes at all. You can set it like that. I think the name of the game is changing these capacitors out. But not that one. Not now that we know this is a special one. That one has to stay. Yeah, and that's for tomorrow. I'm done for today. Got the radio to operate. With the radio operating, I can now go ahead and make changes and repairs, like change out capacitors. And if I make a mistake, it will become obvious because the radio will stop functioning. Like it should only get better from here. Either no change or get better as I change these parts out. If the radio didn't work, and I went ahead and changed these parts, turn the radio on and it doesn't work, is it because of I made a mistake, or is there something else wrong? Or is it, and it's not long before you get into a horrific jackpot of having made 2 or 3 of your own mistakes in a radio that also has other problems, and try to sort all that out. Wow. Mistakes in replacing components are very difficult. When you replace a component and you incorrectly wire it into the radio no longer behaves the way the schematic will tell you, and the whole thing can become really convoluted as you try to find out what has gone wrong. The last thing you want to think is you've made a mistake, but that's actually maybe the first thing to think of. So anyway, that's why I will be very careful, and I will do these 1 or 2 capacitors at a time. And I will anticipate, I will determine what the capacitor is in there for. The one I take out I will test. I have capacitor tester here. I can test and judge the quality of the capacitor I'm taking out. Can't be terrible because the radio is operating to some degree. I usually start at the audio end and work my way up to the radio end. With this one I may start at the radio end because it appears that it's not receiving well, and I'm indicating where each end is. I'm not absolutely sure that's where they are. So, okay, well, thanks a lot for watching to this point, and tomorrow we will take steps to clean it all up and get it into good working order, and then we'll think about testing the tubes, and we'll think about aligning the radio. That's kind of how this is going to go. Thanks a lot for watching. See you on the next video.